Hi, my name is Karl Schmieder, and for the past 15 years, I've been helping biotech companies tell their stories. They use those stories to sell more products with consumers, get partners, or get investors. Last year, I published a book called What's Your Bio Strategy that I co-authored with John Cumbers of SymBioBeta. The book explored the reasons why companies needed to consider biology as part of their innovation strategy. We were motivated to write the book because we kept hearing people say, what's your digital strategy? What's your robotics strategy? What's your AI strategy? And most recently, people have been saying, what's your blockchain strategy? But no one was really saying, what's your bio strategy? How do you get your business ready for the biotech century? 21st century is supposed to be the century of biotechnology. What's interesting is last year in 2017, Inc. magazine ran an article saying that synthetic biology was one of the best places to start a business. Now, I don't know about you, but for me, most people reading Inc. magazine have really no idea what synthetic biology is. And I know this because when we went out and were writing the book and doing the research for the book, we ended up talking to chief innovation officers at some of the leading firms in the world, as well as innovation firms. And across the board, we kept hearing the same thing over and over again. We don't need to worry about synthetic biology for 5 to 8 years. It could be an interesting thing for us to talk to our clients about, but it's not something we need to worry about. And actually, when we would tell these innovation officers about some of the things that were happening in biotech, especially in consumer biotech, they would want to have a longer conversation and learn where we're coming from because they didn't realize some of the progress that we're making. So in this presentation, I'm going to talk about why you need to have an innovation strategy that includes biotech. And it starts out by understanding that biology is programmable, that you can create great value when you design with biology, and you need to have that bio strategy. So let's talk about biology being programmable. As you may know, almost all life on planet Earth operates on a common code. It's these 4 letters that are known as DNA. We all have them in us. Everything that lives on Earth contains it. There are a few organisms that use RNA as their code, but in general, life on planet Earth works on this common code, DNA. Over the past 50 years, we've gotten really good at reading or sequencing DNA, and we've also gotten really good at writing it or printing it. And as we've gotten better at reading and writing it, it's gotten much cheaper. And as it gets more cheaper, it allows us to use biology more effectively and add it to our innovation palette. And when you think about it, when you start to be able to use biology the way that nature uses it, and you're able to program it, you're able to work at the nanoscale, the smallest scale that biology operates at, but also the megascale. So here's the smallest bacteria that we know about, and here's also one of the biggest living organisms on Earth, General Sherman. Biology also works in every color. This is a slide from Scott Fulbright of an Algae Inc. company in Denver, and you can see that biology works in every single color. These are mostly anaerobic bacteria that produce these colors in nature. We can harness that ability to create new kinds of dyes that might not be as damaging to the environment as those that are petroleum-based. In addition, biology works in every environment on Earth. And being able to use biology the way that nature uses it opens up this tremendous palette for innovation. Biology lives, bacteria and aerobic and anaerobic bacteria live at the bottom of the ocean in places that would kill us as humans because we cannot withstand either the heat of the thermal vents or the pressure of the ocean. As I said before, it operates in every color. And then you've got these wonderful living organisms, the tardigrades, that have been proven to live under extremely dry conditions. And if we're going to be able to go into space and populate the rest of the solar system, we're going to need to understand how to better use biology so that we can take these things with us. You might wonder why. Why does it matter? Well, we already know, and we live it every day, that biology creates great value. And when you take biology and you take things that normally on their own might not be very valuable, but you combine them, all of a sudden you create great value. So these ingredients in this slide are those that people use to create beer. You've got barley, which on its own might not have too much value. You've got hops in the middle, which doesn't really have that much value. You put them together, you add water, and you add yeast, all of a sudden you've got beer. And then in the United States, I've heard a statistic that says that pretty much everyone lives about 10 miles away from a microbrewery. We've lived through this microbrewery explosion over the past 10 years. And what that means is that if people weren't making money from brewing beer, there wouldn't be all those microbreweries. And that infrastructure is actually very important to some of the things I'm going to talk about going forward. When people ask me about biotechnology or synthetic biology, they generally want to talk about medicine, they want to talk about GMOs, and as soon as I bring the conversation back to fermentation and wine, all of a sudden their ears perk up and they get very interested. Because unfortunately, when people think about biotech, they either think about guys in a lab coat or they think about guys like this, suits and ties. This is Herb Boyer and Stanley Cohen. They started Genentech back in the 1970s. That was one of the first commercially viable biotech companies. It grew very large, and about 5 years ago it was purchased by Roche. But now we're moving into a place where biology is becoming much more accessible. And synthetic biology is a group of individuals who have self-identified as wanting to make biology easier to engineer. It's software engineers, it's hardware manufacturers, and it's also people taking the tools of biology to do things that previously would have been impossible or would have only been done by companies, big biotech companies. For those of us who are in biotech, we like to say that biotech 1.0 is a lot like the early internet. So email, static web pages, and that's biotechnology from the 1970s, even up to the present day, where you're taking a sequence from an organism, putting it into another organism, and you're producing a protein. However, with biology becoming easier to engineer and the rise of synthetic biology, what we're starting to move towards is Web 2.0, which happened in the early 2000s, where all of a sudden being able to create websites which was much easier. You had user-generated content, and now we're all carrying around cell phones that connect to this wonderful World Wide Web, and creating content and creating value on that web is much easier than it ever has been. And that same kind of thing is happening with biotechnology, where it's becoming much more accessible, it's becoming easier to use, and people are soon going to are already creating value with tools that are out there and that are much more accessible to them. As a result, you need to have a biostrategy. You need to start thinking about why you need to incorporate biotech, biology, synthetic biology into your innovation strategy. Now, usually when people talk about strategy, they like to start off with these tomes on strategy, Michael Porter on strategy, or they'll talk about the art of war. And instead, I'm going to just tell you a story about a DJ. A few years ago, Billboard magazine ran a story on Diplo, who's one of the most well-known DJs on the planet. And the story started out by saying the most valuable backpack in Los Angeles contains 2 laptops, and it belongs to Diplo. One laptop contains his mixes, which he's getting paid, $50,000 to $100,000 for, and the other laptop is his gig laptop where he's doing gigs, and at the time he was getting paid about $250,000 per gig. These days, the Diplo enterprise is much larger, and there's no way that, if you listen to any radio, for sure you've heard his music. It's very recognizable. It might not be by him, but for sure it's been produced by him. So that story got me thinking. A few years back, there had been a book called The $1 Billion Molecule, and so I started to wonder, what does the $1 billion laptop look like? And given that I work in synthetic biology and I'm helping these biotech companies tell their story, of course, I thought that laptop would be something that contained a code, a metabolic sequence that codes for a protein or codes for an organism that would be worth billions of dollars. About a year later, this story came out in Science. This team at Stanford University, led by Christina Smolke, had coated yeast so that it could produce opioids. Now, what most people don't know is that legal opium, the painkiller, is mostly comes from poppies that are grown legally in Tasmania. Yes, there is a lot of illegal opioids out there, and in the United States, we're having an opioid crisis right now. But what was interesting about this story was, if you think about it, and these women did do this not by hard coding it and creating these pathways in bacteria, but actually did it all on a computer, which is possible that they could do. All of a sudden, they open up multi-billion-dollar markets around the world because there are hundreds of millions of people that do not have access to painkillers. So if you can imagine taking that yeast, the same way that you take yeast to create beer, but you take it and you put it into an infrastructure that is a beer-producing infrastructure, all of a sudden you're able to brew painkillers for people who have no access to them. This story didn't get a lot of play. And, from a pop culture point of view, there's a small reference to it in Mr. Robot, but it didn't really get that much interest, and it's because most people aren't really paying attention to biotechnology, even though in many ways it touches us every day. Synthetic biology has created a number of startups, and there's this very rich ecosystem. This slide comes from CB Insights, and this just shows you some of the application areas where biotech is currently being applied. And it goes from healthcare, as you would expect, to reimagining how we create industrial chemicals, to biofuels, to consumer products such as printed leather from Modern Meadow or spider silk protein from companies like Bolt Threads. So if you've got an innovation palette and you're looking to do innovation in a company, you need to make sure that biology is a part of that, and that you also have a biostrategy that incorporates biotech and makes it a part of your innovation strategy. If you'd like more information, you can contact me, Karl at messagingLAB.com, or you can check out the book at what'syourBiostrategy.com. That's all one word, what'syourBiostrategy.com. Thank you very much. Feel free to ask me any questions.